Hi there and welcome. I'm Rebecca Weaver. This is section 6.4. We're looking at areas in the XY plane. So we're looking at the definite integral still, and a geographic interpretation of the definite integral is what we're going to be looking at. So for our definition of the definite integral, suppose that f is a continuous function on a closed interval a to b with antiderivative capital F. That is, capital F prime of x equals f of x. The definite integral of f from a to b is the integral from a to b of f of x dx, and it equals that antiderivative evaluated at b subtract off the antiderivatives evaluated at a. The numbers a and b are called limits of integration, with a being the lower limit and b being the upper limit. The number capital F of b minus capital F of a is the net change of the function capital F as x varies from a to b and is abbreviated by the symbol capital F of x evaluated from a to b. And we've also discussed that the area between the curves, or the area underneath the curve, now we're going to do the area between two curves. And if y equals f of x lies above y equals g of x from x equal a to x equal b, the area of the region between f of x and g of x from x equal a to x equal b is the definite integral from a to b of f of x minus g of x with respect to x. So let's look at an example. We'd like to find the area of the region between y equals 2x squared minus 4x plus 6 and y equals negative x squared plus 2x plus 1 from x equal 1 to x equal 2. So for the solution of that, we're going to graph this, and we have this graph written here, and we can see we need to figure out which one's above. So you graph them, you figure out which one's above, and for ours, it looks like our f of x, where we have it equal to 2x squared minus 4x plus 6, lies above the negative x squared plus 2x plus 1. Therefore, we just plug this into our formula, subtracting off those two functions, evaluating, finding that antiderivative and evaluating from 1 to 2. And you'll see that we get as that answer, that area is exactly 3. So let's do another example. Let's write down a definite integral or sum of the definite integrals that gives the area of the shaded portion of the figure. Now you'll notice that we have two separate pieces here, and our first piece from 1 to 2 is going to be positive, and our second piece is going to be negative. And they want the area of the shaded portion of the figure, so we need to figure out what that means. Now, since the two shaded regions are disjoint, we have two different functions on top. So we're going to need a separate integral for each. So we're going to write this as the area from 1 to 2. It'll be the integral from 1 to 2 of f of x minus 0, which would be that y equals 0 line, or the integral from 1 to 2 of f of x dx. And then the area from 3 to 4, the 0 line, the y equals 0 line is on top. So we would write that as the integral from 3 to 4 of 0 minus f of x, or the integral from 3 to 4 of negative f of x. So if we want to represent all the shaded regions and we don't want to subtract off a portion just because it was underneath that x-axis, we need to be sure and have that negative sign to accommodate for that. So for another example, we're looking at two rockets that are fired simultaneously straight up in the air, and their velocities are given in meters per second, and they're v1 of t and v2 of t. So one rocket, two rocket. And respectively, v1 of t is greater than v2 of t for t greater than 0. So that means v1 of t is on top. Okay. Let A denote the area of the region between the graphs of y equal v1 of t and y equal v2 of t for in between 0 and 10 for t inclusively. What physical interpretation may be given to the value of A? Now, since V1 of 2 is greater than V2 of t for t greater than 0, this suggests that the first rocket is always traveling at least as fast as the second rocket. Therefore, we have the area from 0 to 10 of V1 of t minus V2 of t, all with respect to t. We can break that apart if you want to make it a little easier to look at. In other words, we can find those two position functions and evaluate them from 0 to 10. So here we have our same thing that we had, but again, since v1 of t is greater than v2 of t for t greater than 0, we know that the integral from 0 to 10 of the subtraction of those two velocities is also going to be greater than 0. So this implies that the position functions, when you do that antiderivative, is going to be greater than 0. This means that the position of the rocket is always at least as high up in the air as that of the second rocket. That is, the first rocket is always higher up than the second rocket, or at least the same height. All right, and that is the end of this section. Y'all have a wonderful day.